Preparing for a QA engineer at Tata Elxsi interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is the difference between SDLC and STLC, and how do they work together? SDLC covers the complete software lifecycle, from requirements through maintenance, while STLC focuses specifically on verification and validation activities. I begin testing during requirements analysis by identifying ambiguity and writing acceptance criteria. During design and development, I prepare test cases, data, and environments. Execution, defect tracking, regression, and closure follow implementation. Integrating STLC with SDLC enables shift-left testing, improves traceability, and catches defects before they become expensive production failures. While answering, define both life cycles, explain testing activities in each development phase, mention test planning, requirements traceability, defect reporting, exit criteria, and how early QA involvement reduces rework. Question 2. How would you create a test strategy for an automotive infotainment system? I would start by mapping requirements to risks, navigation, audio, Bluetooth, voice commands, camera feeds, and vehicle signals. The strategy would combine requirement-based functional tests with interoperability, usability, performance, security, and recovery testing. I would cover different head units, phones, operating systems, network conditions, and temperature or power scenarios. Automation would handle repeatable regression, while exploratory testing targets user journeys. Safety impacting behavior requires strict traceability, review, and controlled evidence. Make sure to cover functional, usability, integration, compatibility, performance, security, and safety-related testing, alongside hardware variations, connectivity, traceability, risk prioritization, and realistic vehicle or simulator environments. Question 3. What is the difference between verification and validation? Verification asks whether we are building the product correctly. Validation asks whether we are building the right product. Reviews, inspections, static analysis, and requirement checks support verification without running the software. Validation uses executed tests, usability evaluation, and acceptance testing to confirm real user needs. For an infotainment feature, reviewing its design against specifications is verification, while testing whether drivers can use it safely and intuitively is validation. In your answer, distinguish building the product correctly from building the correct product, include reviews versus execution, provide a practical example, and connect both activities to requirements and customer expectations. Question 4. How do you design test cases from a requirement or user story? I first clarify the requirement and convert acceptance criteria into observable behaviors. Then I identify positive flows, invalid inputs, boundaries, alternate paths, permissions, timing, and recovery conditions. Each test includes clear preconditions, data, steps, expected results, and traceability to the requirement. For a volume field accepting 1 to 100, I test 1, 100, 0, 101, blank, decimals, and non-numeric input. Peer review helps reveal missed assumptions. Be sure to mention requirement analysis, acceptance criteria, positive and negative scenarios, boundary values, equivalence classes, preconditions, expected results, traceability, and review with developers or business stakeholders. Question 5. Explain equivalence partitioning and boundary value analysis with an example. Equivalence partitioning divides inputs into groups expected to behave similarly, so one representative from each group can provide useful coverage. Boundary value analysis concentrates on edges, where defects commonly occur. If a field accepts ages from 18 through 60, partitions include below range, valid range, and above range. I would test 17, 18, 19, 59, 60, and 61. Together, these techniques reduce duplication while preserving high-risk coverage. While answering, define both techniques, explain why representative values reduce test volume, identify valid and invalid partitions, and show how boundary-focused tests expose common implementation defects. Question 6. How would you prioritize testing when the release deadline is unexpectedly shortened? I would not simply test features in development order. I would rank areas by customer impact, safety or compliance risk, usage frequency, defect history, and recent code changes. Critical workflows such as startup, authentication, connectivity, and core media playback receive priority, followed by targeted regression around modified components. I would automate or parallelize repeatable checks, communicate excluded coverage explicitly, and document residual risk so stakeholders make an informed release decision. In your answer, discuss risk-based prioritization, business impact, safety or compliance consequences, critical user journeys, recent code changes, regression scope, stakeholder communication, and transparent residual risk documentation. Question 7. What is the difference between severity and priority in defect management? Severity measures how badly a defect affects the system, while priority measures how urgently the organization should fix it. A crash in a rarely used diagnostic screen may be high severity but lower priority. A small branding error in a launch campaign may have low severity but high priority. I assess both independently, support them with evidence, and discuss disagreements with product and engineering teams. Priority can change as release plans or customer impact evolve. Make sure to define technical impact versus business urgency, give contrasting examples, explain who usually assigns each attribute, and mention reassessment when customer impact or release timing changes. Question 8. Walk me through a strong bug report you would create for a product defect. My report would use a concise, searchable title, followed by build number, device or vehicle configuration, operating system, network state, and reproducibility. I would provide minimal numbered steps, expected behavior, actual behavior, frequency, severity, and business impact. Screenshots, video, logs, timestamps, and relevant test data make diagnosis faster. I avoid assumptions about root cause and verify the issue on a clean baseline before assigning or escalating it. Be sure to cover a precise title, environment, build, reproducible steps, expected and actual results, evidence, frequency, severity, logs, timestamps, and enough context for efficient developer investigation. Question 9. How do you investigate a defect that developers cannot reproduce? I first compare environments, builds, configurations, data, timing, permissions, and network conditions between my run and the developers. I capture logs, screen recordings, timestamps, and exact steps, then repeat the test enough times to identify intermittency. Next, I isolate variables by simplifying the scenario and testing on another device or simulator. I share a minimal reproducible case and evidence, then pair with engineering to determine whether code, infrastructure, or external services are involved. In your answer, explain environment comparison, exact data and timing capture, logging, isolation, repetition, variability analysis, minimal reproduction, and collaborative debugging without prematurely blaming code or infrastructure. Question 10. What is regression testing, and how would you build an effective regression suite? Regression testing verifies that changes have not broken existing behavior. I would organize the suite into smoke, critical path, feature, integration, and extended regression layers. Stable, repeatable, data-driven checks are strong automation candidates, while usability and exploratory scenarios remain manual. Selection should reflect code changes, dependencies, defect history, and business risk. I would run smoke tests on every build, broader suites nightly or before releases, and regularly remove obsolete or flaky cases. While answering, explain regression purpose, smoke versus full regression, risk-based selection, stable automation candidates, maintenance, test data, traceability, execution frequency, and reporting of coverage and failures. Question 11. How would you approach API testing for a connected vehicle or media application? I would validate each endpoint's contract, including methods, headers, authentication, authorization, schemas, status codes, and error payloads. Tests would cover valid, missing, malformed, duplicate, oversized, and unauthorized requests. For a vehicle service, I would also verify state persistence, idempotency, retries, timeouts, and stale connectivity. I use tools such as Postman or Rest Assured for functional checks, then add contract and performance tests so dependent services remain compatible. Make sure to cover request methods, status codes, schemas, authentication, authorization, headers, payload validation, negative cases, contract testing, retries, latency, persistence, and downstream service behavior. Question 12. What is the page object model, and how does it improve UI automation? Page object model separates page locators and interaction methods from test scenarios. For example, a login page exposes enter username, enter password, and submit methods, while the test describes the business flow. When the interface changes, I update the page object instead of many tests. I keep assertions mainly in tests or dedicated components, use stable selectors, and apply explicit weights. For highly dynamic applications, component objects and API setup may improve maintainability further. In your answer, explain separation of locators and behavior from test logic, reusable page methods, maintainability, synchronization, readable tests, component handling, and limits when pages are highly dynamic. Question 13. How do you reduce flaky automated tests in a C pipeline? I treat flakiness as a defect, not a reason to add unlimited retries. I stabilize data and environments, replace fixed sleeps with condition-based weights, use reliable selectors, and isolate tests from one another. Every failure should collect logs, screenshots, traces, and videos. A limited retry can identify intermittent behavior, but quarantined tests need owners and deadlines. I monitor pass rate, rerun rate, and time to repair so C remains trusted. Be sure to mention deterministic data, explicit synchronization, isolated environments, stable selectors, retries only for diagnosis, failure artifacts, dependency control, quarantine policy, and tracking flakiness as an engineering metric. Question 14. Describe how you would test a feature that integrates Bluetooth with an infotainment system. I would test discovery, pairing, authentication, permissions, profile support, contacts, calls, audio streaming, metadata, and disconnection recovery. The matrix should include supported phone models, operating systems, firmware versions, multiple paired devices, and different connection orders. I would add range, interference, low battery, power cycle, ignition cycle, incoming call, and media interruption scenarios. Automation can validate repeated state transitions, while real devices are essential for compatibility and user experience issues. While answering, cover pairing, reconnection, supported profiles, multiple devices, discoverability, permissions, audio or call behavior, interruptions, range, power cycles, compatibility matrix, and negative scenarios. Question 15. How would you test a system when network connectivity is intermittent? I would define expected behavior for connected, disconnected, slow, and recovering states before testing. Using network throttling or simulation, I would interrupt requests during upload, download, authentication, and synchronization. I would verify timeout handling, bounded retries, caching, queued actions, duplicate prevention, data consistency, and clear user messaging. Recovery should not lose or corrupt state. I would also test repeated transitions because reconnection bugs often appear only after several cycles. Make sure to discuss offline behavior, reconnection, timeouts, retries, caching, synchronization, duplicate requests, data consistency, user messaging, network simulation, and defining acceptable degradation before execution. Question 16. What is the role of C/CD in a QA engineer's workflow? C/CD gives QA continuous feedback instead of waiting for a final test phase. A pipeline can build the application, run static checks and unit tests, deploy to a test environment, execute API and UI suites, and publish reports. I would place fast smoke tests as an early quality gate and schedule broader suites later. Failed pipelines need actionable artifacts and ownership. Quality gates should block genuinely risky releases without hiding failures through indiscriminate retries. In your answer, explain automated quality gates, build triggers, test layers, parallel execution, artifact retention, environment provisioning, feedback speed, branch strategy, and handling flaky or blocked pipelines responsibly. Question 17. How do you perform root cause analysis after repeated production defects? I begin with evidence, logs, monitoring, deployment history, requirements, test results, and the exact customer impact. I reconstruct the timeline and use 5 whys or a fishbone analysis to separate trigger from underlying causes, such as ambiguous requirements, missing environment coverage, or weak validation. Corrective actions may include code fixes, test additions, monitoring, process changes, or better tooling. I verify effectiveness through targeted regression and review whether similar paths remain exposed. Be sure to cover evidence collection, timeline reconstruction, 5 whys or fishbone analysis, escaped defect classification, process and technical causes, corrective actions, regression additions, and verification of preventive effectiveness. Question 18. How would you test software involving safety-critical behavior? For safety-related behavior, I start with hazards, safety requirements, and traceability from each requirement to tests and evidence. I verify normal, boundary, degraded, and fault injection scenarios, including sensor failures, invalid signals, timing violations, and power loss. Expected behavior must be deterministic and fail safely. Reviews, independence, configuration control, and formal defect handling are essential. I would align with applicable organizational and industry standards rather than relying on ordinary feature testing alone. In your answer, emphasize hazard-based testing, requirements traceability, independence, fail-safe behavior, boundary and fault injection, deterministic evidence, standards awareness, change control, and never equating functional correctness with safety. Question 19. How do you decide what to automate and what to keep manual? I automate tests that are frequent, deterministic, stable, data-driven, and expensive to repeat manually, especially smoke, API, regression, and compatibility checks. I keep exploratory, usability, visual judgment, and rapidly changing scenarios primarily manual. The decision considers risk reduction, maintenance cost, tool capability, and setup complexity rather than automation percentage alone. For example, automated Bluetooth reconnection loops are valuable, while evaluating whether voice prompts feel natural still needs human judgment. While answering, discuss repetition, stability, risk, execution cost, data setup, return on investment, exploratory judgment, usability, visual assessment, maintenance burden, and using automation to complement rather than replace testing. Question 20. Tell me about a time you found a critical defect and handled it under pressure. During release testing, I found that a connectivity failure could leave the application showing stale vehicle data after reconnection. I reproduced it across 2 builds, captured logs, assessed the customer and safety implications, and immediately informed the lead with clear evidence. Engineering reproduced the issue, implemented a state reset fix, and I added targeted interruption and recovery tests. We retested affected integrations before release and documented the lesson by strengthening offline state requirements and regression coverage. Make sure to structure the response with situation, task, action, and result. Explain evidence, impact assessment, communication, containment, retesting, release decision, and a preventive improvement afterward. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.